So next question is 5. Okay, so question 5 is here given the frequency. Okay, not sorry, we have to find frequency, and some data is given. Okay, so data, what data is given? So data is given question 5. What question is saying? Question is saying something means frequency. We have to find frequency in centimeter inverse for wave rotational in the spectrum of NO. Okay, so this is NO, and NO molecule due to change of quantum numbers from Z to J1 to J2. Okay, so what is the frequency for this pure rotational spectrum of NO molecules? Okay, so simple. Here given some data. Moment of inertia I 1.64 2.7 to 10⁻⁻⁶ kilojoule, sorry, kilogram meter inverse. Okay, and Planck constant is given and speed of light is given. So using these data we have to find the frequency. Okay, so how to solve these types of question? So first see the energy required for transition from J to J+1 state, which is given here. So first we have to find energy. Okay, energy is equal to h nu, where and this energy proportional to frequency. Okay, so if we find the energy, then we will get the frequency. Okay, so E is equal to J to J+1 transition, which is equal to 2b J+1, because here the transition taking place J+1, so here I am written J+1. So transition is given now in question J is equal to 1 to 2. So now put the transition 1 to 2. So here if you see J+1, here written J+1. So now transition taking place 1 to 2. So here we'll direct write put 2. Okay, so 2 is 4. So 4 into B, where B is the value h upon 8 pi square IC. So these are the given constant value. So after putting all these values, h is Planck constant and pi is the 8.13, means 22/7 here whole square, and this moment of inertia 1 this. Okay, so you will get 6.81 centimeters. So this is the frequency in terms of energy. Okay, now this question is very lengthy question. Calculation is lengthy, but if you remember the formula, then you can easily solve. Okay, so here given some rising opening reaction of cyclopropane to propane, okay, at room temperature. And here given the some pre-exponential factor a 4.3 into 10 to the power 15 centimeters, and here we have to find the entropy, which is in the joule Kelvin inverse mole inverse. Okay, so some other data here: Planck constant, Boltzmann constant, gas constant, R value is some given. So we have to find activation entropy. Okay, so if you see is if you read the question, in the question mentioned we have to find the entropy. First I am reading the question. So question is, for the rising opening reaction of cyclopropane to propene at room temperature 25 degrees centigrade, the pre-exponential factor is 4.3 into 10 to the power 15 centimeters inverse. The entropy of activation, which is in joule Kelvin mole inverse rounded off decimal places, is. So here the activation energy we have to find. So simply apply the formula. Activation, as we know, the activation energy is equal to RT upon Na, and is this the Avogadro number, H is Planck constant, into exponential of 1 minus delta Ng, and delta Ng is the difference of gas, okay, numbers of gas molecules here, and into exponential of del S activation upon R. Okay, so here we find the activation, this entropy. Okay, so actually we find this entropy, so we separate these terms. Okay, exponential of del S entropy upon R we have to separate here, we have separate. Okay, now if we put this side and this goes this side, so A multiply this and divided by this, okay, into divided by this. So here I am writing here, okay, I am written here like this. So simply 1 minus delta Ng is the here rising opening reaction of cyclopropane to propane, okay, cyclopropane to propane. Okay, so here the ring opening is happening, so 1 mole of cyclopropane and 1 mole of propane, so delta Ng is equal to here 0. So here if you put delta Ng, so you will remain the exponential of 1. As we know, the exponential is the into the power 1 is equal to exponential, so exponential E is value 2.718. okay, so we put the 2.71 in place of exponential. Okay, so as we know, in given the question, pre-exponential factor A is given 4 point this, and Na Avogadro number is given. Okay, as Planck constant is given, and R is given, gas constant, T is room temperature 25 convert to Kelvin, and this 2.71 exponential value. Okay, okay, now after this solving, we will get this value. Okay, this value, because if you see this 23 and here the power minus 34, so if you subtract this you will get minus 11, and now 15 minus 11 is equal to 4, so I am here written 10 to the power 4, and remaining 10 digit you multiply, then you will get this value. Okay, now divided by this, if you multiply this value you will get this value, and now divide by this value to this, you will get this value. Now if you see the left side is exponential, so after first we have to remove the exponential, so taking ln on both sides. So if you take ln on both sides, so here ln into exponential you will get only 1. Okay, So here the exponential will remove. Okay, so delta S activation upon R equal to ln this value. Okay, ln this value. So now this term goes to this side into multiplies, so you will get delta S activation. You know R is the gas constant, and put the R in and put the ln 254.75, you will get this answer. Okay, so these are the easy question, but the formula is big. Okay, this is 6th question. Okay, so now now next question is next question. First I erase this, then I will tell you next question. Right, so next question is related with NMR. Okay, mix IR and NMR. Okay, so question is, a compound with molecular formula is given C10 S12O2 shows the strong IR band at 1720 minus 1720 centimeter inverse. Okay, a peak at mz, molecular weight is given mz 122 in a mass spectrum, and the following 1H NMR signal, some 1H NMR signal is given. Okay, so we have to choose the which one is the correct compound using given data. Okay, so question 7 is given compound molecular formula is given C10H12O2. okay, and IR peak, IR band is strong band is showing 1720 centimeter, and this indicate A star. Okay, if this types of band come, then you can say guess the A star will be present on your compound. Okay, and molecular mz is given 122. okay, and 1H NMR 1H NMR signals is given 8.1280 multiplicity, okay, 7.6 to 7.5 1h multiplicity, okay, 7.5 to 7.3 2h m 4.32h to triplet and 1. Sextet and last 1 3h triplet. This data is given, okay, given data in your question, and here is the option A is given like these molecules. Option B is given Me and this benzene. Option C HO, and last option is this, okay. So you have to select which one is the better compounds, okay, right. So first, according to the question, here ester is given, so first you check ester is present or not. So here ester is present, here is not present, okay. So this will not the correct answer. So okay, first you cancel out, this will not the correct answer, okay, and this will not the also correct answer. Maybe this will be in computation, this will be in computation. So you have to fit all these data, okay, and also this is not in conjugation, okay, because here the not in conjugation, but this is conjugation, this like this, okay. This is conjugate, that's why the correct option is this, not this, okay. So correct option this, and you can fit all these data, your and this compound will also fulfill, okay. So hopefully you understood. So next question, so next question is from radiochemistry. Okay, so question is question is saying the fission reaction of uranium 922, okay, with thermal neutron is represented below, okay, and niobium and Sb are the primary fission fragment pair which undergoes series of radioactive decay to form stable nuclei X3 X4 chain and okay X3 X4 respectively. So we have to find the X3 X4 respectively. Okay, so how to approach these types of question? Okay, first you see uranium is fission, okay, so bombardment of neutron, then you will get uranium 92 to 36. Okay, after that it convert to Nb, divide to Nb and Sb, and then again primary fission fragments is happened. Okay, undergo this radioactive decay to form the X3 X4 stable. Okay, then we have to find X3 X4. So okay, okay, so this question I will tell you in next lecture. Okay, 2-3 question is only remaining. Okay, so in the next lecture I will solve. Okay, so okay, thank you, bye bye, good night, all the best. Okay, so hopefully you guys understood all these 7 questions. Okay, so if you have not subscribed my channel, so please subscribe and like my channel and click the bell icon so then you can get easily notification when I upload the video. Okay, thank you.